Second part for carbohydrate metabolism, we are going to insist more on the different steps. So we start with glycolysis. This is where you break down a glucose molecule that contains 6 carbon into 2 molecules of pyruvate and some energy. There's only 2 ATP molecules that are made and 2 NADH molecules which are intermediate. So I am not going to ask you to know all the steps. Just know there's about 10 enzyme catalyzed reactions that break down each glucose molecule in those pyruvate. But you need to know the overall result. So net production of 2 ATP, because you need 2 ATP to start that split of the glucose, and then you're going to make 4 ATP at the end. So you consume 2 and you make 4, the net product is going to be 2. Then those intermediate, as I mentioned earlier, NADH from NAD+, and you should also know that glucose has 6 carbon, that's what you have here on the far left, and is going to be converted into 2 molecules that contain 3 carbons. Now, glucose is not the only monosaccharide that our body metabolizes. We can, of course, ingest fructose, galactose, mannose. Those are all eventually going to join the glycolysis pathway. Those sugars are also metabolized by the bacteria that exist in our mouth and in our digestive system. So those are just examples where you find fructose, galactose, and mannose. So again, here I'm not asking you to know all the steps, but just understand how fructose actually can get included into glycolysis. There are 2 ways. In muscle cells, it's phosphorylated to become a fructose 6-phosphate, and in liver cells, it is converted to glyceraldehyde 3-phosphate. Both of those are going to integrate glycolysis in different steps. I don't ask you to memorize 3 and 6. Galactose, well, galactose from the hydrolysis of the disaccharide lactose is converted to glucose 6-phosphate, which is directly getting into that step 2 of glycolysis. And mannose is coming from the hydrolysis of plant polysaccharide other than starch, converted by the hexokinase multi-step enzyme catalyzed rearrangement to become fructose 6-phosphate and become available for entering glycolysis.